In math, every operation has an opposite. Subtraction undoes addition, square roots undo squaring, and so on. Trig functions also have opposite operations called inverse trig functions. The notation for the inverse trig functions is a little confusing because it looks like an exponent of -1, like sine to the -1 for inverse sine. When we learn about negative exponents, we discover that they're related to fractions, such as x to the -1 means 1 over x. That is not what we mean here in the context of trig functions. More recently in math history, people have tried to mainstream some less confusing notation by using the word arc for inverse, such as arcsine for inverse sine, but the original notation sticks around on calculators and such. Any trig function has an inverse, but we'll focus on inverse sine or arcsine, inverse cosine or arccosine, and inverse tangent or arctangent. Again, those first notations do not mean 1 over sine or 1 over cosine or 1 over tangent. They mean to reverse the process of taking a sine, cosine, or tangent. When we see the equation tangent of theta is equal to 5 over 6, this tells us that there's a right triangle whose opposite and adjacent legs to the angle theta are in the ratio 5 to 6. They might actually be bigger, like 10 and 12, since 10 over 12 simplifies to 5 over 6. But let's draw a simplest form triangle with legs 5 and 6. If I needed to, I could use the Pythagorean theorem to find that the hypotenuse length is square root of 61. To solve for the angle theta, we simply need to undo the tangent function. We do this by taking the inverse tangent of each side of the equation. Tangent and inverse tangent cancel each other out, and we have theta equals inverse tangent of 5 over 6. From the information we have so far, there is no possible way for us to know or calculate by hand inverse tangent of 5 over 6, so we'll need a calculator. If we go to the Desmos calculator, we can find the inverse functions in the function menu. Select the function we want, enter the side ratio, and we get an angle in degrees. If we want the angle in radians, we just need to click the radian toggle switch. The angle theta is 39.8 degrees or 0.69 radians. For those continuing on to trig, you'll get a lot of practice recognizing special angles and the special ratios that go with them. Someone brand new to this would need a calculator to solve for t in sine of t equals 1 over square root 2. But someone with enough practice would recognize that the ratio 1 over square root 2, opposite over hypotenuse, comes from the 45-45-90 triangle. In this case, we don't need a calculator because we can see from the triangle that the angle must be 45 degrees, which is pi over 4 radians. In other words, inverse sine of 1 over square root 2 or arc sine of 1 over square root 2 is 45 degrees or pi over 4.